Hello guys, how are you? So in this project I want to show you how it is the implementation of control, measurement and saving of the fan temperature information. So first of all I'm going to show you the introduction of this project, and then we go for the software of Arduino for see how it is and all of the pictures. So the idea in this project with Arduino microcontroller, I'm using the MKR1010 of Arduino microcontroller, is using a thermistor, or finally I use a Dallas sensor of temperature, take the proper decision if turn on or turn off a fan when the temperature is higher than 30 degrees. So also in this project we need the proper component implemented. So for example, I am here, I have with the Proteus software I have 7.5 volts. So I'm using the regulator because Arduino needs 5 volts from function. So I go for in to Arduino. Here I'm reading the temperature measurement with ADC. This is pin of ADC, and then I'm taking a decision with the pin GPI of 3, and like an output I go for a MOSFET. I'm using this model of MOSFET. And of the regulator is this model. So I take a decision and I turn on the fan. This is the resistor, and the diodes are for not have problem with the current. If I have a highest current here, don't damage my fan or something in the circuit. So then I'm going to show you the photos of the microcontroller that I am using. You can search in internet, but I'm going to leave you here in my folder. Here is all the pin out of this microcontroller and the photos also, and all the libraries. It's very important to include the libraries in the software. So going to the file, Arduino file. This is the pin configuration. You can see this is, I am not using the thermistor finally. So but if you want to use the thermistor, also there are files for do the proper implementation of this one, and also if you can read my project, and here you have a lot of information for the good implementation that I was searching with the values, because you need to use the Steinhardt model coefficient for the thermistor, for the ADC lecture. Also for have more precision, I was using LabVIEW with these machines for have the same measurement of the temperature of the time. Then you can see. So these are the pin configuration of Rtc that I'm using. The module is like this one. This is module Rtc. Then ACD card shield pin configuration. Here you have 5 volts. CCS is pin 4. So these are the car shield. This is like this one with these connections that I'm using for save my measurement of the temperature. These are the Dallas that finally I am using this project. I am using for take the data, the pin 2. So this are the Dallas sensor of temperature. It's not a thermistor, sorry, you need yes or yes 4.7 k ohms. So well, if you, this is comment, if you want to use a thermistor ADC, you can discomment this. Remember that I'm using 47k thermistor. Also, you need in parallel, in parallel you need another 47k resistor for have 25 degrees. Then you can search in internet or whatever you want. If you not, you can ask me. So starting is very important for this project. You can see all then the code, all the code. But it's very important to include all the libraries that I leave you there in my files that I'm going to send you. So these are the libraries. This is I'm using BLYNK also and ThinkSpeak for sending information and for seeing real time what I'm doing. So with BLYNK and ThinkSpeak you can see this is for the out token for BLYNK. It's very important. Okay, for the module of Wi-Fi that have my microcontroller. If not, I recommend you use a ACP module of Wi-Fi. If not, you can ask me then. This is the password of my router. These are the definition, the first definition, the libraries, you know. For ThinkSpeak, and then I start with the setup of the Arduino. So you know that is the first step. The setup is the first step that the microcontroller does. So here we do these first steps. I am using all the time. For example, this is a function. So you come here and you can see you have all the functions. For example, I don't know, the function ACD car setup temperatura. This is a function. So this is for the proper implementation of the ACD car shield for save your information that you want. Here is for save. I am saving 3 files of the ACD car. I am saving temperature, day and hour. So then you can see in different file in the ACD car shield all the measurements that I am taking in this time and this date. So it's very nice. So then I am going to the loop. This is the that the microcontroller do all the time. So I am putting a delay here. You can comment this. It's not important, but it's better for me put here a delay for wait. So I am starting BLYNK run, timer run. These are internal function of the library of BLYNK. This is RTC BLYNK internal RTC BLYNK of BLYNK for see the clock, for see the hour and send to BLYNK. Then I am calling my RTC module. This is for the thermistor temperature, but it's comment I'm not using. I'm using the Dallas. So this is the function. If we come for this function, this is the function. I am doing here an average. This is very important. I am doing an average with a 4. Because it's better for have more precision in the measurement that I am taking. So I am taking 5 measurement and then I divide 5. So I have here I have more precision when I am taking and sending the temperature that I have in this moment, in this specific moment. So then when I send the temperature, I am taking a decision of 30 degrees. If it is the temperature, it is 30 degrees high, 30 is high, So if it is up, sorry, I am taking a decision to turn on the fan. Also with Blink you can turn on the fan with a switch. So if you switch on the switch of Blink, you going to turn on the fan also. Okay, it's very interesting project. So then I am calling all the ACD car shield functions. So these are for the loop, for save all the time in the measurement of the temperature, hour and date. Then I am calling the blink app. I am sending the information and also to ThinkSpeak, and then I put a delay for wait. So in this project I have 2 seconds of delay. If you plus this with this one, you have 2 seconds. Okay, and this is the project. It's very interesting because we are taking a decision with the temperature, we are measurement, we are saving the information. We have also our RTC module for the hour and the day. So it's very interesting project. And that's it. So I hope that you enjoyed this project. Okay, see you then, guys.